ladies and gentlemen, today we are going to use a factor tree to determine the GCF of two numbers. Just a different strategy in determining the greatest common factor, a little bit different than what you had done in the past with the factor keys. This works on reducing both numbers down to their prime factorization. How many of you have heard that word, prime factorization? So the smallest numbers, the numbers that don't have any other factors, that make up the bigger number. And that'll make sense here in a second. So I'm going to need your help a little bit. The number 12 has a whole bunch of factors that go into it. Please give me 2 that when multiplied together give me 12. Gloria?
3 and 4.
So we're going to use 3 and 4. So we're going to start our factor tree, which sounds like most of you know what that is. And we are going to say 3 times 4 is 12. And that's true. Then we're going to look at the new number 3 and the new number 4, and we're going to determine, does 3 break down into any other smaller factors? And by the way, 1 in itself, so 1 and 3 don't count. Are there any other factors that go into 3 besides 1 and 3, everybody? No. So we're going to go ahead and we are going to box 3, because we can't do anything more with that. Then we're going to go over to our next number that we produced, 4. And are there any other numbers that go into 4 other than 1 and 4? Isa?
2 and 2.
2 and 2. So we're going to draw our little arrows coming off of 4, and we're going to write 2, and we're going to write 2. Now, do any other numbers other than 1 and 2 go into the number 2? No. So we're going to box 2, and we're going to box 2. And then what we're going to do is we are going to write the prime factorization, the smallest numbers that can't be factored any further for 12 below for our final answer. So we're going to write 2 times 2 times 3, and that is the final answer for the prime factorization of 12. And by the way, is 2 times 2 times 3 12?
Yes.
Okay, cool. So now we're going to go to the number 8, and we're going to do the exact same thing. Please give me 2 numbers other than 1 and 8 that go into 8, Mackenzie Bott.
4 and 2.
4 and 2. Okay, wonderful. 4 times 2 is 8. Next, we have the number 4. Does anything besides 1 and 4 go into the number 4? Samira?
2 and 2.
2 and 2. So we're going to keep going. Samira? Let's just take 2 and 2. Can we break them down any further, or are we done?
We're done.
Thank you, Samira. So we're going to box 2, and we're going to box 2. And then we're going to look at our other number 2, and since we already have looked at a couple of 2s, we know nothing else goes into 2, so we're going to box this 2 as well. So our final answer here is going to be 2 times 2 times 2, and all of you know what a dot means, right?
Yeah.
We did that in a previous wake up, and we're going to box it. Now, I told you that we're going to use a factor tree, which we just did, or a couple of factor trees, to determine the GCF. Have we determined the GCF yet?
Yeah.
No. First of all, when you look at 12 and 8, do you know the GCF by just quickly running through the numbers in your head?
Yeah.
Raise your hand and tell me what the GCF is. Tate.
4.
4. 4 is the GCF. Now, when you get into bigger numbers like thousands and 10,000s and 100,000s, and I ask you to do a factor tree and get down to the prime factorization and determine the GCF of another number that goes along with it, it might not be as easy as just looking at it and saying 4, right? Yeah. So I'm using this strategy to help you with bigger problems that you're going to have in a couple of minutes in your little homework assignment I'm going to give you. So what we're going to do is we are going to take the prime factorization of 12, the prime factorization of 8, and we're going to find common prime factors. So let's start with this 2. 12 has a prime factorization of 2 times 2 times 3, and we're going to start with the 2. Is there a 2 in the prime factorization for 8? Yes or no?
Yes.
Yes, so let's circle. Let's circle this 2, and let's circle this 2. Okay? Let's go back to 12, the prime factorization of 12. There's a 2 here. Is there another 2 over in the prime factorization of 8?
Yes.
Yes, so let's circle them, because we're looking for things that they have in common. Common factors. Get it? Common factors. Okay? Now we have the number 3 here. Is there a number 3 over here?
No.
No, so let's exit. We're not going to use that. We're done with the 12 prime factorization, but let's not forget about the 8 prime factorization. Or, since we're done with all of these, does it matter what's left over here with 12? No. We have a 2 left over, but there's no other 2s for it to go with, right? Because we already have both 2s going with both 2s. You can't double up. So let's cross that out. Now, if we take the common factors for 12 and the common factors for 8, what happens when you multiply 2 times 2 together, you guys? 4. What happens when you multiply 2 times 2 together again? 4. So the greatest common factor for 8 and 12 is going to be 4. And so GCF equals 4. And we just determined the GCF of two numbers by using prime factorization or a factor tree. Does that make sense?
Yeah.
Questions, comments, quandaries, scribbles, quotes, or queries?